Welcome to this lesson. In this lesson, we're going to be learning more about abstraction in Java. And in this lesson, we're going to be learning about interfaces. In the previous lesson, we mentioned that there are two ways to achieve abstraction in Java, and that is through abstract classes and methods, and the second one is through interfaces. So in this lesson, we are going to be learning about interfaces. An interface in Java is defined as an abstract type used to specify the behavior of a class. An interface is a blueprint of a behavior. A Java interface contains static constants and abstract methods by default. The interface in Java is a mechanism to achieve pure abstraction or total abstraction. There can only be abstract methods in an interface and not the method body. It is used to achieve abstraction and multiple inheritance in Java. In other words, you can say that interfaces can have abstract methods and variables. It cannot contain a method body. The Java interface also represents an is-a relationship. By this we mean, if we have an interface called shape and a class called rectangle, we mean that a rectangle is a shape. That is what we call an is-a relationship. A circle is also a shape. When we decide a type of entity by its behavior and not by attribute, we define it as an interface. And like a class, we can have methods and variables, but the methods are declared as abstract by default. The difference between interfaces and abstract classes is that with abstract classes, as we saw previously, it is possible to declare concrete methods that have a definition or an implementation combined together with abstract methods that do not have an implementation. However, with interfaces, you do not define concrete methods. It only allows for abstract methods. So with interfaces, you do not define any implementation for the methods that you write. Again, another difference is that with abstract methods, in abstract classes, you have to define the methods intrinsically or explicitly by providing the abstract keyword, but for interfaces, all methods are by default abstract. Interfaces specify what a class must do, but not how. It is a blueprint of the behavior. Interfaces do not have constructors. They represent the behavior as an interface unless every subtype of the class is a guarantee to have that behavior. An interface is always about capabilities. Like a player may be an interface, and any class implementing a player must be able to implement a move or a play or a stop method. So it specifies a set of methods that a class has to implement. If a class implements an interface and does not provide method bodies for all functions specified in the interface, then the class must be declared as abstract as well. So let's find out with our own example how we can be able to achieve abstraction through interfaces. So in our program, we have defined an interface called shape and using the interface keyword. So notice the syntax that for defining classes, we say public class and then the class name. For interfaces, we use the keyword interface. For instance, public interface shape. We also have two other classes, public class rectangle and public class circle. So we would like to define some abstract methods in this shape interface that we would like the implementing classes to implement. So we are going to define void area, void display, and we can also have another method apart from area and display called display name, void show name. So we do have an interface that has three methods. One is area, the one is display, and the other one is show name. Actually, instead of show name, we can actually have void draw to draw the shape. So you may realize that I have not used the abstract keyword in this while defining these methods, neither have I concerned myself with either saying whether they are private or public. This is because to declare an interface, all methods are public by default. All methods are public by default, and all fields are public, static, and final by default. And that is why we have not used the access modifiers. And also, all methods are abstract by default, so we did not use the abstract keyword. So whenever we want to implement these methods in a different class, we use the implements keyword. Implements is a keyword and followed by the interface that is going to be implemented. So for inheritance, we use the extends keyword, but for interfaces, we use the implements keyword. So it throws us an error and tells us rectangle class is not abstract and does not override the methods defined in the shape interface. So we are going to override those methods because it's a must for us to override those methods. So we have the @override annotation for the area method, and also an @override annotation for the display method, and another @override annotation for the draw method. For these that has been generated by our IDE, we do not need them now, so we are going to remove them for now. We do not need them. So each shape, for instance, the rectangle class is going to define its own method of defining an area. So for instance, for the rectangle class, we may have an int, a private int length, and a private int width to calculate the area. So that whenever we want to calculate the area, we can define a variable called area equals to length times width. Area equals to length times width, and we may output the area. Area plus area. So in this case, let's define, let's give our length and our length some value. So we can say the length is 10 and the width is 5. Equals 5. So those are just some values for the purposes of our calculation of the area method. Then we have the void display. We can have an implementation of the same. Rectangle shape has been displayed. Obviously, in a real scenario, we would actually be drawing a circle, a rectangle. So let's also provide an implementation for the draw method. Draw the rectangle. So we have provided implementations for all the methods, for area, for the display method, and for the draw method. So let's go to the circle class and provide an implementation of the same. Implement the shape method. The shape interface. So we override all the methods, and just as we did for the rectangle class, we provide an implementation for all the methods. So for the circle class, it should have a variable called private int radius. We have the radius that is going to assist us in calculating the area. We can also have, apart from radius, we can define a constant. So we can have final int pi. Pi equals to 3.142. That's the value for the pi, I believe. Compatible types and from double to int, so it's actually a double. So final double, it's actually a double, final double pi. So let's now provide the area. So to provide the area, you can define double area equals to pi multiplied by radius squared. Radius times radius. Radius again, that should give us radius squared. So we can enclose these in brackets just to ensure that it evaluates the square first. And we can output our own implementation. Circle area equals to the area. So we can provide, say, a value for the radius. Radius equals 7. So for the display method, let's have something as well, just to output something. System.out.println. So what I would like you to realize is that we defined an interface that says that every shape must have an area, and it can display the shape, and we can also draw the shape. And for every other implementing class, we do not have to redefine this method because they are blueprints. But what we do is that we provide an implementation for every class that we are working on, and that is going to be implementing the same interface. So let's define a private variable again here, just to make our code, just to make it more intelligent. So private string name, let's actually call it shape name. Actually shape equals to circle. So when we are displaying, we're going to say displaying the name of the shape. Displaying shape. Let's copy this, and instead of displaying, we are going to say drawing. Going to say drawing. Drawing the shape. Yeah, so I think we can also define the same for the rectangle, just to make our code more intelligent. Private string name, string shape equals to rectangle. And we can say displaying the shape, drawing shape. So we have provided implementations for the same classes, and for the same classes for the interface. So let's provide a main method that's going to run the code. Public static void name. string array of arguments. So we are going to create an object of the type rectangle. Rectangle rect equals to new rectangle. So using the default constructor, so let's call a method called rect dot area. So let's have rect dot area. Let's have another one, rect dot display, and another one, rect dot draw. So let's run our program and find out how this works. So what we expect is that from the implementation is going to take the methods from the interface, and we have provided an implementation for the same. Yeah, so we do have an output and tells us that the area is fitting and that is drawing the shape rectangle automatically, and it is displaying the shape rectangle. So let's try the same for the circle class. Remember, they are all using the same methods which have been defined or declared in the shape interface. So for every shape, we are implementing our own different implementation of, for instance, the area class, the display method, and the draw method. So let's define a main method, public static void main. It takes an array of string arguments. So we define a circle object equals to new circle. So we can call the circle dot area, and call another one circle dot draw, and finally circle dot display. What I want you to realize is that, for instance, in the area method, it is defined in the shape interface. However, the rectangle class has its own implementation of the area, in that the area is the length times width, and the circle class also provides an implementation of the area method differently, in that the area is pi r squared. That is the difference that I want you to find out. And however, both are using the same interface and it is the same method. So this is to emphasize the point that the interface is only used to provide a blueprint or a structure for the implementing classes, and to define how the general structure is supposed to be obtained. So let's find out the implementation of the circle class. Very good. So we have the circle area which has been calculated as 153.958, and it is drawing circle, displaying circle. So key takeaways from this lesson: how we achieve total abstraction or 100% abstraction using interfaces. How do we define an interface? Using the interface keyword. For instance, we have public interface shape. Another key takeaway is how do we define interface methods? They are by default abstract, and they expect to be implemented in the implementing classes. When we come to the implementing classes, how do we implement an interface? Using the implement keyword. For instance, we have public class rectangle implements shape, and the requirement is that whenever you implement an interface, all the methods in that interface have to be overridden, and that is why the shape interface provides us three methods: area, display, and draw. And the rectangle class and the circle class all have to override those methods. That's why we have an override annotation for the area method with its own implementation, and an override annotation for the display method and also a net override annotation for the draw method. The same also happens for the shape class. We have public class circle implements shape, and also it overrides all the methods that have been defined in the shape interface. Thank you very much for staying on course. I hope you have learned more about abstraction using interfaces. See you in the next lesson. Thank you.